Integrated Math 2. This is lesson 1.02. The subject is called similar figures. So what is a similar figure? So let's go ahead and write down a definition. Okay, similar figures are two geometric shapes. They could be triangles, parallelograms, pretty much anything, etc., that have the same angles but different length sides. So these two figures they're telling you are similar. So we don't know what this angle is, but what we do know is that this angle A is the same as this angle A. This angle B is the same as this angle B. This angle C the same as this one. And this one, it might be a right angle, but I'm not sure. It doesn't make it clear. So we just call it D and D. But you can see that this side is clearly longer than that side. So what you're doing very simply is you're picking two sides. The sides are all proportional to each other. And it means you could pick any two sides. So what I want to do is, I know that this side corresponds with the 7. So I'm going to put x on top of a proportion. And proportion is simply two things that are related, two relationships that are related. And I'm going to put 7 on top of a proportion. Now I could do x over 126 equals 7 over 14. I could do x over 90 equals 7 over 10. I could do x over 36 equals 7 over 4. So you'll notice that all of these sides are 9 times greater than these sides. So 9 times 10 is 90. 9 times 4 is 36. And 9 times 14 is 126. So 9 times 7 is going to be this, x. So what we do is we just say x is to, I'm going to pick 90. X is to 90. As 7 is to 10. So that's called a proportion. Whoops, not 7 is to 7. 7 is to 10. That's called a proportion. It means there's a relationship between the two. That this one, if you were to reduce a fraction, think of this, if this is a fraction and this is a fraction, and you reduce them, you would get the same reduced fraction. But the way you solve a proportion is you cross multiply each of these terms across the equal sign and then divide. So let's write that down, that rule. That's the rule for doing all of these. Okay, so what we have is 90 times 7 equals 10 times x. 90 times 7 is 630 equals 10x. We're going to divide both sides by 10. This cancels, and that means 630 divided by 10, you can do that on a calculator if you need to, it's going to equal 63. So this side equals 63. Okay, let's just prove that by using a different side. So let's say 7 is to 14. So we just used these two. Now let's use 7 is to 14 equals x is to 126. Okay, cross multiply. And you get 14x equals, and 7 times 126, I'm not going to try to do that in my head. It's 882. You now divide both sides by 14. These 14s cancel, and what you get over here is x equals 882 divided by 14 equals 63 for x. So same number. It didn't matter which side you used, you just had to use related sides. Okay, so you didn't have to do this twice. This was enough. Just showing you that you could have used a different side and come up with the same answer. So cross multiply and divide. Okay, let's keep going. One thing you can quickly do is, if you're good with doing multiplications in your head, you can kind of look and see what the relation. This is 4 times this side right here. If you know your times tables, this is 4 times this, which therefore means this is 4 times this. So this is going to be 4 times this. But I still want you to set up the proportion. So I'm going to say, now I'm going to show you a different way you can do it. You can say, instead of doing x is to one of the sides of its own triangle, you can do the relationship x is to its corresponding side. Corresponding side means it's the similar side of the different triangles. So this side and this side match up with each other. So I'm going to do it with corresponding sides. X is to 3 equals, and this is an easy one to do, 40 is to 10. So these two sides correspond, and these two sides correspond. All right, so you cross multiply, divide by 10 to get x by itself, cancel, and you get x. Write x on the left side usually, and I'm off screen, I see. X, write it on the left side, equals 120 divided by 10, that equals 12. So x over here equals 12. Okay. Let's do it a second way. I'm not going to always do this, but let's do it a second way using two sides of the same triangle. So I'm going to say x is to 40. We'll use these two sides. So x is to 40 as, that's what the equal sign means, as 3 is to 10. So I'm using two sides on the same triangle now, instead of corresponding sides on a different. Okay, you multiply this, you get 120. And you multiply this and you get 10x, and look at there, you get the same thing you got the last time. Now, it didn't have to be. If I had done it with 12 and 56, I would get different numbers, but I'm going to end up with the same answer. That's the important thing. So divide by 10, divide by 10. This cancels out, and you again end up with x equals 12. Okay, in either case. And I could have done it two other ways using the other sides. Okay, so that's how you do it. It's very simple. It's setting up a proportion. You cross multiply and you divide. Okay, let's go on. All right, so we're on to number 3. So this one's pretty straightforward. This side is to this side. 2 is to 2 equals x is to 6, and you don't even really have to do a lot of math. X equals 6. This is going to be 1, so this has got to be 1, 6 over 6. So that's x equals 6. Now, again, the other thing you could have done is you could have said 2 is to x, and you may say, well, why do I want to do it this way? That seemed easy enough. But you could say 2 is to x as 2 is to 6. In other words, you compare corresponding sides of the two triangles, or the two squares rather, and so obviously x has to equal 6. You don't even have to do math to see that, okay? So your answer is 6. I tend to go with doing the sides on the same geometric figure equals the ratio of the sides on the other geometric figure. So that's the way I tend to do these. Okay, all right, so here we go. So we can see what the corresponding sides are, x and the 16. And the 8 and the 32. So we're going to say x is to 8 as 16 is to 32. And some of you can do this in your head. Whoops, I'm not even on screen, sorry. Let me do that again. So x is to 8 as 16 is to 32. That's what I wrote right there. Okay, so again, some of you can do this in your head. I'm going to still cross multiply, do it the proper way that you have to do it sometimes. And 8 times 16 is 128. Okay, divide both sides by 32. And you have that equals 4. So x equals 4, and of course 4 is half of 8, and 16 is half of 32. So that's how you do that. Okay, we'll keep going. Again, same thing here. 10 is to 11 as x is to 88. Cross multiply. 88 times 10 is 880. And 11 times x is 11x. Divide both sides by 11. These cancel, so you get x equals, that might take a calculator, and that gives you 80. So this is 80. I'd like to have you write the number, the answer, near the x, so you see, you can, visually see what that 80 means. It's the side, it's that side over there. All right, we keep going. I'm going to make this a U problem. I got to do every once in a while, give you one to do on your own. So this ought to be straightforward. Do it just like the one up above. Okay, it looks almost exactly like the one up above. Just the triangle's a little bit different shape. All right, so that one's a U problem. Here we go. Keep going. So you can all see that. This is to this, as this is to this. Cross multiply there, you get 330 equals 10x. Divide by 10. So you need to get x by itself. And you get x equals 33. There it is, and the 33 would go right there. All right. They're making these pretty straightforward. It doesn't matter. You could do 56 over 48 equals x over 6, or you could do 48 over 56 equals 6 over x, as long as the corresponding sides are the same. So I'll do it both ways. Watch. 56 over 48 equals this over this equals this over this. Okay, so we cross multiply. 6 times 56 is 336. And I think that's going to give us a whole number, I'm pretty sure. And it gives us 7. Now I'm going to do it the other way. I'm going to do 48 over 56. Equals 6 over x. Cross multiply. You get 48x equals 336. So notice you get the same thing. You got the same thing both places. So x, that should be equals. X equals 7. Okay? Those are your answers. We keep going on. So now it says determine if the figures are similar. There's a couple ways you can do this. You can reduce a fraction. Okay? So this fraction, 7 over 15, is reduced. You can't reduce that any further. So let's see if we reduce this as a fraction, 28 over 60. So I'm going to put a question mark above the equal sign. That means, is it equal? I'm asking, is it equal? Is 28 over 60. So let's reduce that fraction. So you can see they're both even numbers. So I'm going to divide 28 by 2. And that equals 14, and divide 60 by 2, that equals 30. You still have even numbers. So I'm going to divide 14 by 2, and I get 7, and I'm going to divide 30 by 2, and I get 15. And yes, they do equal each other. Okay. Another way you could have approached this is just imagine you didn't know this side. You do know it, it's 60. But imagine you didn't. So how would you have set this up? I'll come over here and do this. You would have said 7 over 15 equals 28. And I could have picked any of the sides to replace. But I'm going to replace the 60 with an x. So I'm going to go ahead and do it the way we've done the previous problems. I'm going to cross multiply 7x equals 15 times 28 is 420. Divide both sides by 7. That cancels, and x equals 60. So since I got the number of the side that I replaced, that I pretended like I didn't know, it is correct. They are equal to each other. Okay, that's a way to do it. So either one of those ways you want to do this. All right, let's try this one. Remember, you can always stop if I'm going kind of fast. You should always do this anyway. Try to do every problem on your own and then watch me do it. And then if you didn't know how to do it and you watched me do it, then go back and do it on your own until you can do it. Do it as many times as you have to until you can do the problem without watching me. Okay, so here's the same kind of thing. So you could pick any two sides, 5/7. I'm picking this side and this side. And that doesn't reduce as a fraction. So we're going to ask, does that equal to the corresponding sides, which would be this and this, 6/8. And if you reduce 6/8, you get 3/4. So 5/7 does not equal, that's what that symbol means, does not equal 3/4. So the answer is, they're not proportional, they're not similar. So the answer is no to that one. Again, you could have done it the other way. I'll just do this one more time. 5:7 equals, I'll replace this number, the 6. X is to 8. So I'll pretend like I didn't know that number and see what I come up with. Cross multiply, you get 40. 7 times x is 7x. Divide by 7. Divide by 7. And what you're going to get here is about 5 point something. I don't know. But it's not going to be 6. It's going to be 5 point something. You want to do the division over here. If you want to see it done all the way to the end, I'll do a decimal division here. 7 goes into 45 times. That's 35. Okay, and then you subtract. You get 5. You bring down the 0. You get 50. 7 goes into that. There's a decimal point there 7 times. So you get 5.7. You do not get 6. Okay, so it does not equal. So no, that is not proportional. All right, let's keep going. I think I'm going to leave one more for you to do. Again, does 4/12, this over this, equal, question mark, does it equal 2/6? Well, you can reduce both of those fractions. So 4/12 divide by 2, you get 2/6. Well, look at there. You don't even really have to reduce them any further. 4/12 is the same as 2/6 because it reduces down to 2/6. Divide that by 2, divide that by 2. And that's what you have here. So you don't even need to go any further. They do equal each other. So the answer is yes to that. They are proportional. Or you could have done a substitute one of the sides with an x. Oops, I'll get on screen. Substitute one of the sides with an x like I did on the previous one. I'm going to leave this one for you to do. I think this one's pretty straightforward, not too hard, number 12. So this is a U problem. You do that. And I'll answer any U problems if you come to tutoring. If you really feel stumped and you want to come to tutoring. But those are the ones that I check. I check to see that you're not just copying the answers that I'm doing. So be sure you do that. Okay, that takes care of 1.02, and we will see you on the next lesson.